All right, hello Math 20-2 students. So today we're going to be moving on from polygons, which we looked at in lesson 2.4, and getting back to some information about triangles. Specifically, we're going to be looking at congruent triangles, and this will be what we'll look at for the next two sections, so 2.5 as well as 2.6. But just to start out, let's do a quick little bit of review and practice from what we've already done leading up to now. So here we have two sets of parallel lines or a set, I guess, of parallel lines with a transversal, and we're being asked to label the following angles. So first of all, they want us to label all of the corresponding angles. So remember that corresponding angles basically mean they're in the same spot as each other, but just on the opposite parallel line. So for example, if we start with A, for example here, it's on this inside upper part of the outside, I guess, upper part of this parallel line, and next to the transversal, like the transversal is on the bottom, and so E would be the corresponding one, because on the next parallel line it's also on the top side of the parallel line and the transversal is running along below it. So corresponding angles would be angle angle A is equal to angle E. If we move down, angle C here, so on the lower part of the parallel line, is corresponding with angle G. So we can say C is equal to G. If we move over here, angle B is corresponding to F. So we can say B equals F. And lastly, we can say that D is equal to H. So they are also in the kind of like the same spot, D and H. Okay. What about alternate interior? So remember, this means that the interior part is always referring to the parallel lines. So if it says interior, it means it's on the insides of those parallel lines. And then alternate means that they're on the opposite sides of the transversal. So alternate is always referring to the transversal. And so our inside angles are C, D, E, and F. But if we're looking for alternate interiors, then we would have C is on the other side of the transversal with F. So we can say C equals F. And the only other one we would have there is D is an alternate interior with E, so we can say D equals E. All right, what about alternate exterior? Same idea, but they're on the outside of the parallel lines. So we have A, B, G, and H as our exterior angles. A and H are on opposite sides of the transversal, so that means they're going to be equal. And B and G are on opposite sides, so they are also going to be equal. So B equals G. Okay. Now what about supplementary? Supplementary, you're always going to find a lot more of those because they're basically all the angles that add up to 180. And so essentially if we start with A, it's anything where you could move across that angle and include another angle and it would make a straight line. So we could say A and B would be supplementary, so A plus B. Now remember, this is a little bit different with supplementary. These angles are not equal to each other, but if you add them together, they will equal 180 degrees. Then if we moved over, we could do B plus D would also make 180. D plus C, so if we keep going around the circle, and C plus A are also going to make a straight line. So you can really see there how you can find supplementary angles basically all the way around a circle. And so then we would have the same thing down here. So we could do E plus F, F plus H, H plus G, and lastly G plus E. Okay, now the last one we have here is opposite. So remember, opposite angles are always in, like if you think of the two intersecting lines kind of like an X, they're always going to be directly across from each other. So if we start with A again, the opposite angle from it straight across is D. So A equals D. Now we're back to finding that these angles are going to be equal to each other. And then if we move around here, B is going to be equal to C. On this side, we're going to have E is equal to H, and F is equal to G. Okay, so those are all of our different types of angles as a bit of a refresher. Now the other part is review a little bit about polygons as well as a little bit about triangle properties, and that's going to help us move into what we're looking at today. So in this question we're asked to determine the measure of angle BEF. Okay, so just so we can easily identify, let's just highlight that. So angle BEF is right there. Oh, nope, I'm going the wrong way, guys. BEF. Let me, I don't know if I can really do anything with that. Let me just see if I have another. Oh, there we go. I'll make it purple. BEF. There we go. Okay, so that's the angle we're looking at. And so we want to figure out basically what is this angle here. Now, if we look at where this angle is located, we can see that it's in a triangle. So we know that angles in a triangle add up to 180. So if we knew this angle, then we could solve for this angle. And we also have this angle down here, 42 degrees. Now, because this isn't a 90-degree angle, it's not going to be complementary, so we can't do that math. But if we have 42 degrees here, this line and this line are parallel. This intersecting line is going to be a transversal. And we know that this angle up here is on the inside of the parallel line, as is this one here. And they're on opposite sides of the transversal, right? This one is on top of the transversal and this one is below the transversal. So thinking back to the angles that we just looked at, or the angle properties, that would be alternate interior, and so we know that these two angles would be equal. And since we're given this angle already, that makes it easy to solve for angle B over here, which would be 42 degrees. So we can say angle EBF is equal to angle other way around, BED, angle BED. And so then we can say angle EBF, which is the one that we wanted to solve for, is going to be equal to 42 degrees. Okay, and the justification for that is because we have alternate interior angles. Oops, alternate interior. And then, like I mentioned before, since we already know that this shape here is a triangle, now we know two other angles, so we can solve for this one by doing 180 degrees minus 66 degrees minus 42 degrees is going to be equal to 72 degrees. So we can say angle BEF, which is the one we were looking for, is going to be equal to 72 degrees. And the property that we can quote there is that angles in a triangle equal 180 degrees. Okay? I don't know, I accidentally left a third spot blank there, but we don't actually need to do that because we've already proved it in just two statements. Okay, one more piece of practice before we move on to today's material. So in this case, we aren't given any specific measurements, but we're given algebraic terms, and we need to determine the measures of A, B, and C. So basically, one thing that we could, because we don't have any numbers to add up to, the first thing we could start out with that's actually going to give us a number value is if we look at up here at the top at angles A. Well, we know that 3A and 7A are going to be supplementary. So that means they're going to add up to 180 degrees. So if we fill in an algebraic term basically that represents that, we would say 3A plus 7A is equal to 180 degrees, right? Now, remember from previous learning that when we have numbers that are being multiplied by the same variable, you can add them together. So we can say 3A plus 7A is going to be equal to 10A, which is equal to 180 degrees. Now if we want to solve for what is A, right, because we're trying to figure out the measure of A, we can isolate it by dividing out 10. So we can say A is equal to 180 degrees divided by 10, which is going to be equal to 18. So now we can say A is equal to 18. Now just keep in mind that doesn't give us the actual measures of the angles, it just gives us the value for A. So we would still have to multiply by these values to determine the specific number values there. So essentially we would say 3 times by A, which is 18, is going to be equal to 54 degrees. Okay, so that would be 3A equals 54 degrees. And then for 7A, it's going to be 7 times by 18, which is going to be equal to 126 degrees. And so we can say 7A is equal to 126 degrees. Okay, and the justification that we used for that was the supplementary property. Supplementary. Okay, now let's move on to angle B here. With angle B, does it have a relationship to any of the angles that we've already solved for? Well, angle 7A it doesn't really work with, right? Because it's alternate, but they're not both interior, so that doesn't work. However, if we compare it with 3A, we can see that these are corresponding angles. So we can actually say 3A is equal to B, and we know that we calculated 3A as being equal to 54 degrees, so then we can say that B is equal to 54 degrees. So B equals 54 degrees, and our justification for that was that they were corresponding angles. Okay, now last one here, we have 2C. There's different ones that you could use. So if we look at the relationship here, it's on the exterior of the parallel lines, so is 3A, and they're on opposite sides of the transversals. So we could say that they are alternate exterior. You could also say, because it's directly opposite B, you could use the opposite rule as well. So either one of those will work. I think on the notes that I posted for you guys that were filled in, I did opposite, so maybe let's do the other one here so that you can see that both are an option. So we can say 3A is equal to 2C, and 3A we said was 54 degrees is equal to 2C. And so if we want to solve for just C, that means we need to divide out the 2. So we can say C is equal to 54 degrees divided by 2, which is going to give us C being equal to 27 degrees. And that was the rule of alternate exterior. Now, if you would have used the exterior justification, or sorry, the opposite justification, you also would have had to do the same exact math, right? Because B would have been equal to 54, which would have been equal to 2C, and then you would have divided out the 2 the same way and come up with the same value. Okay? All right, so let's move on to new information for today. We're looking at congruent triangles. And what is a congruent triangle? Well, basically, if two triangles are congruent, it means they will have exactly the same 3 sides and exactly the same 3 angles. So the equal sides and angles may not be in the same position, like the triangle could be flipped or turned around, but they will be there. So for example, if we think about just sides, here you can see this triangle here, it has 5, 4, and 7, is congruent to this one because you can see that they just like mirrored the triangle over. So even though it's in a different position, the actual triangle itself is not different because it still has this long side of 5 and then 4 and 7 here on the hypotenuse. So you could also look at this one here, and this one would also be congruent to either one of these, because essentially what you've done now is you've taken this initial triangle and you've basically like flipped it over like that, because now the 4 is on the bottom and the 5 is going up the left side and then the 7 is connecting right there. Okay, so those are congruent triangles based on sides. The other thing is that they have to have the same angles. So here, if we look at this triangle here, it has an angle of 40, 110, and 30 degrees. So this one is congruent to this triangle, even though it's flipped over, right? Like you can see that they flip the triangle this way, but having just the three angles isn't good enough. They also have to be the same size. Okay, so if this triangle would have had the same angles but have been way different proportions size-wise, then you would not be able to say that it was congruent. Okay, so just kind of keep those things in mind as we move forward, because what we're going to look at now is our proofs that we have for saying that different triangles are congruent. So the first proof you can use is called SSS, which is for side, side, side. And so basically all you're looking at is if the triangles have three pairs of corresponding sides that are equal. Okay, so for example, this one right here has oops, sorry, I just realized that I moved this paper off. Okay. Sorry, so these two triangles, you can see that, just keep in mind that when you have the same markings, it means those sides are the same length. So if there's just one tick, then the side with one tick will also be the same. If there's two, then this one would be the same. And if there's three, then that one would be the same. And so basically what we see is that these two triangles are congruent. Now it's pretty obvious with these ones because they already told us that. Usually when you're doing like a problem, you'll have to determine the missing side or something like that to see if you can use this proof. But basically all you would do then is to make you have to make something called a congruency statement. So it's kind of like what we've been doing so far when we've been giving proofs and justifications, or statements and justifications for angles. So essentially what you want to do is make three statements that say that the sides are the same. So we could start out by saying here, side AC is equal to side, or actually let's start out with AB maybe. So AB is equal to the one over here with three strikes, which is XY. So AB equals XY. And then now, again, like in this one, it's pretty obvious that they're talking about a side because that's what we're given. But usually when you're writing out your justification, you're just going to put in brackets that it's an argument based on side, okay? The next one, so if we go down here, we could say side BC is equal to side YZ. Okay, and that's also going to be a side proof. And then lastly, if we go CA is going to be equal to, or let's do it alphabetically, AC is equal to XZ, which is side. Okay, and so those are my three statements that prove side, side, side. And so then I can say therefore, remember this little triangle of dots means therefore, triangle ABC. So we just draw the little symbol for triangle. And then this weird kind of thing where you have an equal sign with this squiggly line over top of it means is congruent to. Okay, so triangle ABC is congruent to triangle XYZ. Okay, and that's basically all you do for a congruency statement. So let's go through the other three types of proofs that we have. The next one is side angle side. So this is where you have triangles are congruent if they have two equal corresponding sides and the angle formed by those two sides is equal. So this is where you have to be careful and pay attention, because the angle that you're looking for to be the same has to be between the two sides you're using as proofs. So for example, I couldn't use an angle up here if I'm using these two sides. It has to be the angle that's connecting these two sides. Okay, so if I'm going to use side AB is the same as side XY, right, because they both have one tick. So then my first statement is going to be AB equals XY, and that's a side argument. Then my next has to be the angle, so I'm going in order around the triangle, and that's an easy way to kind of remember it, right? This is why we set it up as SAS, because it has to go two sides that are the same, two angles that are the same, two sides that are the same in order as you're moving around the triangle. Okay, so now I'm going to say angle B is equal to angle Y, and that's my angle argument. And then lastly, I can do my last side, which is BC is equal to YZ, because they both have two ticks, so that's going to be this side, right? And so again, I can make my final statement, which is therefore triangle ABC is congruent to, so equal sign with the little squiggle, triangle XYZ. Okay, now the last type of proof we have is angle side angle. And so this is where you have two triangles that are congruent if they have two equal corresponding angles, and the side that's between those two angles is equal. So here you can see we have this angle, angle B and angle Y are equal, and then angle C and angle Z are equal. So the side that we're talking about has to be in between. And so again, the way that we label this argument tells us it has to go angle, side, angle in order through the triangle. Okay. So for example, we couldn't have angle B and angle C congruent to Y and Z with, you know, this side being the same one, because the side isn't in between the two angles. Okay, so really quickly, how would we write out the proof? Well, we have to start out with angle B being equal to angle Y, and that's an angle argument, so we can write that in. Then we have side BC is equal to side YZ, which is a side argument. And then last of all, we have angle C is equal to angle Z, which is an angle argument. And again, we can say therefore triangle ABC is congruent to triangle XYZ, just like that. Okay, so those are our three proofs that we're going to be using for triangle congruency as we move forward. So let's give an example a try here. So for the pair of triangles, state why it is possible to label them as congruent triangles. So basically we have to come up with a proof of why we could call them congruent. So if we look at the measurements, it's pretty obvious, right? We have 4.6 centimeters here, 2.4 centimeters, and 5.7, and visually looking at the triangles, you can see that those are that they're similar triangles, right? And so with this one, because we have all side measurements, we're going to use side, 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 right? We don't want to try and figure out angles if we don't have to. So or basically, sorry, I shouldn't say that. It's not just angles. It's basically like look at the information that you have when you do these questions and try and make the most out of that. If you then have to find some other information, then you can do that. But you want to start out keeping things as easy as you can. So let's say side AC is congruent to the other 5.71 is XZ. So AC equals XZ, and that's a side argument. AC, let's see, side BC is equal to side ZY, or YZ maybe I should say. BC is congruent to YZ, which is also side argument. And then we have AB is equal to XY. Also side argument. And so we can say therefore triangle, they really like to use these same three letters, triangle ABC is congruent to triangle XYZ. Okay, so that was a really, really easy one, just to kind of get us started. But let's look at things that are a little bit more tricky as we move forward. So the first one here, is it possible to conclude that the following pair of triangles is congruent? Explain your reasoning. So let's look at the information that we have. We have an angle here, an angle there, and we have a side. And if you look at this triangle over here, you could probably tell there's a 42 and a 110 right next to each other. So you can probably see that if you could rotate this triangle, it would look exactly the same. And then after the 110, we have the 4 centimeters. So that's good news. But the only problem is, remember our 3 possibilities. So we could have side, side, side. So we only have one side, so we don't want to use that. Now the other options we had are side, angle, side. So again, we only have one side, so we're probably not going to use that. And then the other option that we have here is angle, side, angle. And remember what we said about that is that the side we're talking about has to connect 2 known angles that are the same. So our side here is between angle B, or angle Y in this one, and angle C or angle Z in this one, which are unknown angles. So this means we're going to have to do some calculations because we have to prove these 2 angles based on our congruency statements. Now, fortunately, you can probably tell there's an easy way to solve for those. We have a triangle. We have 2 angles already present. So the first step that we need to do is to find our missing angle. And we know that all the angles in a triangle add up to 180. So this should be pretty straightforward. We're just going to do 180 degrees minus 110 degrees minus 42 degrees. Which leaves us with a 28-degree angle. Okay, so now we can say if we have 28 degrees here and 28 degrees there, right, it's the same measurement. Now we can do our angle, side, angle argument. So we'll start out with our angles. Angle B is equal to angle Y, which is 110 degrees. We need to do side next. So this was angle. Next one is going to be side. So BC is equal to YZ, which is going to be for side. Okay, and then last of all here we have angle C is equal to angle Z, which is an angle argument. And so we can say, therefore, triangle, again, we have the same type of triangle. Triangle ABC is congruent to triangle XYZ. Oops, it's kind of a messy Z there, but you get the point. Okay, now last one, state the corresponding angles and sides and explain how you know that the triangles are congruent. Include a congruence statement in your answer. Okay, so let's look at what we have here. We have 1 tick here, 1 tick there. Okay, so we know those sides are the same. And then we have 2 ticks here and 2 ticks there, so we know those sides are the same. And then in between those 2 sides, we have an angle. And the angles are also the same. So I don't know if you guys know this, but if your angles are the same, then, like, for example, these ones, they're starting out with just the same sign. If you already had 2 like this, then what they might do to show that 2 angles were equal would be to put 1 tick, just kind of like they do on the sides. And then if they wanted to show a 3rd angle was equal, they could do 2 ticks. Okay, so just be aware that you can see the same thing with showing angle similarity as you can with side similarity. Based on those kind of markings. So with this one, we can see that we have 2 sides and an angle. Because the angle is contained by the 2 similar sides, we know that we can use our side, angle, side congruency statement. So now all we basically need to do is start with the first side. So let's say AB is equal to XY. And then angle A is equal to angle X. So this is side, angle, and then lastly our last side is going to be side AC is equal to side XZ. And so again, we can say triangle ABC is congruent to sorry guys, my mic just cut out there, triangle XYZ. Okay, so that's everything for today's lesson. Hopefully that was pretty straightforward. There's some practice problems for you to do on page 99. And next time we'll kind of look at these getting a little bit more complicated. And we'll also do a little bit of, let me just double check that. I think we do a little bit of review from your homework as well. So yeah, we'll go over a little bit more of this next time. If it's not totally seeming to make sense to you yet, don't freak out, because we'll look at it a little bit more in the next lesson. So I will see you then.